Hello and welcome to Intro to C++ episode 2. Today we're going to be covering data types in C++ and we're going to cover other things like basic variable creation. In the first episode we installed WSL in VS Code. It helped us create our very first Hello World program. Very basic. We were able to output to the screen. We learned how to compile. We learned about scary C++ errors. And we made it all easy because we didn't have to deal with Windows crazy compiler installation. So in this video I plan on showing you guys how to do variable creations, how do we create them, how do they store memory, what are good practices when we create variables, and what is the use for each data type. So when we create a variable, we have two things that we say when we create one. We have a declaration and initialization. So I can declare a variable or initialize it. So when we create a variable in C++, we do it because we want to be able to store or manipulate data, or both. And the reason we want to do this is to make it so we can really customize our programs. In the first episode, when we created the Hello World program, we just outputted to the console Hello World. We didn't even make it a string variable. We just put in double quotes Hello World, and we couldn't change what it said there. So in this video, we're going to learn how to create variables, and let's say you'll learn how to create a string variable. You can make it say anything you want by reading input from a user. So the reason it's important where you put variables in C++ is because we need to declare variables before we actually use them. C++ goes line by line, and it's when it looks at the file, it goes by line. It says, okay, does this variable exist? Cool. Did they make a variable here? Yeah. What's its type? What's its value? Hey, they used the variable here. Oh, I know what that variable is. I have it in memory. If we don't have a variable in memory, then we know that, hey, this variable doesn't exist. It's actually undefined. What are you trying to do here? And as we can see in the second example here, I created the age variable after I tried to output it. So it's very important that you know where to put your variables. It's typical when starting to learn that you put a lot of the variable creations at the very top of the function. You don't need to do that. There's a thing about scoping meaning when you know when to create a variable. You can create it inside an if statement or inside a for loop or a while loop. And that will help with how much memory you're using, because if you let the variable destroy itself, essentially you will save more memory in the end. So we can declare and we can initialize a variable. C++ has rules for variables. They can only be named with alphanumeric characters and an underscore. What this means is I can say ABCD underscore EFG, or ABCD underscore, or A underscore, or underscore. However, you cannot start a variable with a number. I cannot say 1 hello, or 2 hello, or @ hello, because the @ sign is not a alphanumeric character. Variables can also not be reserved words. Here's a list of some reserved words in C++. Typical ones you're going to see are true, false, if, else, int, string, char, car, bar, main, blah, blah. It's a lot of what we call keywords. These are words that are used within that the compiler understands, and the compiler needs these to make sure that it parses your file correctly, to make sure that it builds it correctly. So let's cover some data types in C++. These are the primitive data types, is what they're called. We have a bool, which is true and false. We have a char, which is short for character. We have a short, which is an integer. You can also say short int when you use it, but it's better to say short, or easier. You have an integer, which is a larger short. A short is only ranged between -32 to +32,000. Integers from like -1.4 or 1.47 to +2.147 billion. A long can go forever. Not really forever, but it's a very big number. A float, long is an integer, by the way. A float is a number that has decimal places. So you can say you can create a fraction. A double is also like a float, but it has more decimal places. A double has 15 decimal places and a float only has like 6. Each of the above types store different memory. So for example, a bool is 1 byte in size and a byte is only 8 bits, and each bit only holds true and false, so 1 and 0. Or not, they don't hold true and false, but they do hold 1 and 0. It's binary information. So depending on your system, your system could be a 32 or 64-bit. I don't know if I've ever seen a computer, because I'm young, as a 16-bit, maybe a calculator. Depending on the system, it will change how some of these values react. An integer can be between 2 bytes to 8 bytes. I think I've typically only seen it between 4 and 8, and in almost all times I think I've seen it as 4 bytes in size. So that means it supports a pretty big range of information. So why does this matter? What's the difference between choosing an integer and a floating type? Well, with integers like in math are whole numbers, and these whole numbers cannot hold decimal places. In C++, if you create an integer and you try to assign a floating point number to it, the decimal places will be truncated. Truncated means removed or dropped or forgotten. Integer types in C++ again are the short int and long int. You can also just say long. And floating type numbers are, again, numbers that can hold decimal places. An integer can be assigned to a float and not lose any information, but an integer doesn't hold decimal places to lose to begin with, and if it even could, it would be given access. The float would be able to handle it. If you try to assign a double to a float, in this case, a double holds 15 points of precision with decimal places, where a float only holds 6. I'll put a photo here if I'm wrong, don't remember. You will lose that information on the double if you assign it to a float, because it cannot support all of those decimal places. A long double is a large, it doesn't increase the decimal places that it can hold, but it does increase the max whole number. A character or a char type is something that allows us to hold characters. They are typically denoted with a single tick or quote. If you want to use one or compare a character to another character, you need to use the single tick. If you try to use double quotes, double quotes is used for strings. So if you try to compare a character to double quoted, say in this case if the letter D here is in double quotes, it would tell you that those are mismatching types and you cannot compare them, especially with characters and strings. There are special functions for that. A string is a dynamic sized character array. Otherwise, we just call it a string. Don't worry about the array stuff I just mentioned. It is able to grow and shrink depending on whatever we give it. In this case, when I initialize the string here, it is John Smith. It is 10 characters in length. So if I were to get the size of full name dot length, it would return 10. Whereas if I reassigned it later on to Dylan was only 5 characters. A character is always 1, right? Because it's only 1 character. We'll learn later how to take input from a user with string. There are some weird things with inputting from the stream. With C++, you have to use a special function called getLine if you wanted to get more than 1 word, because cin, the standard input stream, can only read up until the first white space, and a white space is usually a space character, that empty, like between John Smith here. Constant variables are very important. Constant variables help us make sure we have data that is important and it should never be changed, and we know it shouldn't be changed. It also helps us with memory management later on when we learn what passing by reference is. It is good to make everything a const if you're never going to change it, because then it creates the idea that we are correct in that this variable is only assigned once and it will never change, so why not make it a const in case, what if it did change later and our program broke because of that? Again, a constant variable cannot be it cannot be assigned again later on, so you have to give it a value at initialization. You'll later learn that in function parameters that you can make variables constant and yes, as it looks like the value changes, that variable itself doesn't change inside that function. Regardless of the type, the const keyword will always be left to the variable type. It's typical that const variables are also all uppercase, depending who you were taught by. I was taught by my professor. Everything is uppercase, except when a function parameter. There are caveats to that. But this goes into a scary topic. Global variables. Please don't do them. I was taught to not do them, so I'm carrying over that tradition or teaching. When we refer to global variables, we are talking about variables that are declared and initialized outside of our function. In our case, it is the main function that we've learned. This means anywhere in the code can access the variable and it can alter it in any way. Depending on who you ask, again, it is taboo to make global variables, and I agree that it's not the greatest because it can really lead to undefined code. The only time it's okay to make a global variable is if that variable is also a const variable, because then even though it's global, it cannot be changed and affect other parts of the code that you're not aware of, especially if your code gets very large and there's lots of lines that you can't keep track of and you're on a team and that team also doesn't know everywhere that it's used. They're not going to keep track of that. So that's it for today's episode. I really appreciate you guys watching. This is really all I had planned because I realized after the first one I mentioned doing logical operators and relational operators, but now that I looked back and rewatched the video a few times, I realized how poor I covered all these topics. And I think I'm going to try out a few different video formats while learning how to video edit. I have no clue what I'm doing. So this time I used Google Slides. Last time I read off a script that I wrote in Word, and I edited on top of that. I think this will make it a lot easier for me. But yes, next time I think we'll get into some basic arithmetic and assignment operations. Today we covered assignment a little bit. There will be a few things we'll learn about assignment in the next episode, such as type differences between variables when we assign. Again, we mentioned the assigning a float to an int, and maybe get some logical operators. So like greater than and less than. We can get some equals, or yeah, the equals is not assignment. That's one thing we really need to drill into our heads later on. So thank you very much for watching. Appreciate it. Bye.